So in this example, we want to map the upper half plane to the interior of the unit circle. And we want to do this in such a way that the origin gets mapped to point -1 on the real line, and the point 1 gets mapped to the point 1. And also we're going to specify that for this transformation, w equals f of z, we're going to say that our z3, which we're going to say is the point at infinity, so f of infinity, we want to get mapped to either this point or this point. Now we can't choose, we have to work it out. So to work it out, oh sorry, I got it wrong. Sorry, I said that wrong. So Z2, sorry, gets mapped to W2, which is either going to be here or here, and Z3 gets mapped to W3, which is here. So we've got, I haven't drawn Z3 because it's at infinity. So to work out where W2 has to be, we're going to make it either here or here, we need to consider the orientation. So basically, when I move from Z1 to Z2, the region I want is on the left. Now, that means that when I move from W1 to, and I could say from Z1 to Z2 up to Z3, which is at infinity, the region I want is on the left. Now, I want the region to be, to be on the left. So if I move from W1 to, and if I put W2 here, then the region I want is on the right, so that's the wrong side. So I need to put W2 here so that the region I want, like here, is on the left. So W2 needs to be here, and I have that, if I just write everything out completely then, that f of 0 is -1, f of infinity we said is +1, and the one thing we just determined is that f of 1 needs to be -I. So we now need to determine the bilinear transformation which does this, and as I suggested, the easiest way to do this is just to use this form. And substitute in these results. So if we put z equals 0, what happens? So this first one will give us -1 is equal to d over b. Okay, putting z equals 0 here gives us d over b. So therefore, minus b equals d. So that means we can actually now just rewrite this as az minus b over z plus b. Probably infinity is the next easiest one to do. So when z is infinity, we get the answer 1. So as z gets very large, we can neglect the d and the b, or neglect the minus b and the plus b, and we just get, as z tends to infinity, we just get the answer a. So therefore a is 1. So actually maybe it would have been better to do this one first, which just leaves the trickiest one, which is not that tricky, but now we know what a and b are. Now we know what a is, we need to find b. We've got when z2 is 1, when z is 1, then we've got 1 minus b over 1 plus b needs to equal -I, which means that we've got -I minus bi is equal to 1 minus b. Just looking at the imaginary parts of, okay, well it's hopefully clear that the only way you're going to get 1 here is if b is equal to I, which also works for the real part, so therefore b has to equal I, and our final answer is, the transformation we want is w is equal to z minus I over z plus I. Now, suppose instead you want to map the inside of the unit circle or the unit disk onto the upper half plane. Then all we need to do is just rearrange this to get z as a function of w. So that would give us wz plus wi equals z minus I, and then just make z the subject. So we've got z times w minus 1 equals minus I minus iw. Therefore z is equal to, we can take out a factor of I, and we've got 1 plus w on the top and 1 minus w on the bottom. So this is if I want to map from the w plane to the z plane. Of course, I can change the letters if I've got a circle in the z plane, and I want a half plane in the z plane. Then I just swap the letters, and I've got w here and z here instead.